Greetings from Math World YouTubers. Today we're going to talk about logs and just kind of the intro to logs. My computer crashed last period, so I don't really have everything that I did before, but we're going to try and make it up as we go. See if I can remember everything that I had written down. The first thing, I had a bunch of equivalent expressions. The first one was log base 3 of 9. The next one was 2. Next one was log base 7 of 49. And my last one was log base x of x squared. They're all the same. Here's why. 3 squared is 9. 2 is 2. 7 squared is 49. X squared is x squared. So all of these are actually just 2, including 2. So let's see if we can make this make sense. So 2 to what power makes 8? 3. Because 2 to the third power is 8. So this one, log base 5 of 1/25, is negative 2. Because 5 to the negative second is 1 over 25. Go back to my video on exponents if you don't get that. That's in there. Fractional exponents and negative exponents are the two things that we struggle with the most. Next thing, what happens if we don't have a base? So our base default is 10. So if there is no base, we automatically assume it's 10. So 10 to what power makes 100? 2. And that's right there. That's our answer. 2. If we have natural log, which is, you can Google it and look all why the L and N comes first, but it's Latin for like logarithmic natural or some crazy thing like that. Anyway, the base for that one is E. E is an irrational number. You can Google that too. It's kind of like pi. E and pi kind of go together there with the irrational numbers that we use over and over and over again. So for this one, it has the base E. So we're saying the answer is 5 because E to the 5th power is E to the 5th power. So this is E to the what makes E to the 5th. So obviously, question mark and 5 are the same. Okay, let's see if we can go one way and then we'll go the other way. First thing is, can we rewrite this in exponential form? So A is 3 to the 4th power is 81. That's all we're asked to do. B, remember the base is E, so E to the power of x is 5. And lastly, C, 2 to the power of negative 3 is 1/8. Now we're going to go the other way. So we're going to rewrite this as log. Remember, it always starts with log. And then the big numbers are base. Log base 2 of 32 is 5, right? And then we go backwards, 2 to the 5th is 32. Here, we got log, and then, kind of tricky, base 3 of 1/9 equals negative 2. And then lastly, log base 81 of 3 is 1/4. Be sure that our 81, our 3, and our 2 are subscript. Our 32, our 1/9, and 3 are all in the same line with log. And then our 5 and all that stuff is on the same line. Please don't write that. That's like log base 10, remember, because we don't have a base now, of 2 to the 32nd. That's not right. We need the log and then the 2 down here and then 32 there. All right, last 4 and then we'll be almost done. So remember, this is, now we're evaluating, so we're getting an actual answer, a number. So this is base 10. So 10 to what power makes 1/100th? Negative 2. If you need to write this, that might help you. Remember negative exponents. Go watch that other video. On letter B, 4 to what power makes 64? Well, 4 to the 3rd power makes 64. Letter C, fractional exponents or rational exponents. So this is log base 4 of 4 to the 1/3. So this is saying 4 to what power makes 1/3? Well, 1/3, right? 4 to the 1/3 power is 4 to the 1/3 power. And last one, D, I need a little more room for this one. We got to get tricky. This is probably the one that we're going to struggle with the most. This is saying 16 to the what power makes 1/32? The answer is not 2. 16 squared is not 32. It's a much bigger number. So I need to rewrite 16 as a power of 2. So 2 to the 4th power, and then still to the x, equals, well, 1/32 is 2 to the negative 5. Then, since I now have the same base being 2, and I can multiply those, I can set those equal to each other. So 4x equals negative 5. So I divide by 4, and x is negative 5/4. The last thing I want to go over is change of base. Change of base formula says that we have log base x of y, we can rewrite that as log of y over log of x. Here, our new base is 10. Now, you might be asking, well, why would we do that? Well, if you get something crazy like this with a log base 43 of 97, I can't put that in my calculator. I have no idea. 43 to the what power? I have no idea. But if I rewrite this as log base 97, sorry, log base 10 of 97 over log base 10 of 43, I can put that in my calculator and do it. So for log base 8 of 9, we're just putting this log 9 over log 8 in my calculator. So let's see if I still have it up. Sure enough, log 9 over log 8, 1.057, round to 3 decimal places. Catch you later. Bye-bye.